Hi guys, welcome back to my channel. So for today's lesson, we will be talking about integral calculus. So integral calculus is the branch of calculus that deals with functions to be integrated. Basically, integral calculus is the opposite or the reverse of differential calculus. In integral calculus, we have two types of integral. We have the definite integral and the indefinite integral. The definite integral is the integral that is defined by the limit values of an independent variable. Basically, this is the integral that have an upper limit and a lower limit, while the indefinite integral is the integral with no limits or its independent variable. So just like differential calculus, we also have our integration rules. So the first one is the constant rule. So given the integral of a constant, it will be equal to ax plus c. So any constant or getting the integral of any constant, it will be equal to the constant times or multiply by x plus the constant c. Example, the integral of 4 dx is equal to 4x plus c. The second integration rule is the variable rule. So the integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1 plus the constant c. For the given example, the integral of x dx, since the exponent of x is 1, therefore n plus 1 will be equal to 2. Substituting it to the formula, the answer will be x squared over 2 plus c. For the third integration rule, we have the multiplication by constant rule. This is where a constant is multiplied to a given variable. The constant multiplied in the variable will be placed outside the integral sign. Therefore, for this example, we have the integral of 4x squared dx. So, since the constant is 4, we will just place 4 outside the integral sign and integrate the remaining variable. So, we need to apply the variable rule in here. So, since the exponent of x is equal to 2, therefore n plus 1 is equal to 3. Substituting it to the formula, we now have x cubed over 3. So, simplifying, we have 4x cubed over 3 plus c. That's the final answer. The last two rules will be the sum rule and the difference rule. In here, we can just integrate them separately. So, the following are the integration formulas. So you just need to memorize them, especially the trigonometric functions. For our first example, let's evaluate the integral of t cubed plus 1. In this example, we can use the sum rule, meaning we can integrate separately t cubed and 1. To integrate t cubed dt, we can use the variable rule. So, t cubed plus 1 over 3 plus 1. Plus, we can use the constant rule here, so it's t. So, simplifying, we now have t raised to 4 over 4 plus t plus the constant c. For our second example, let's evaluate the integral of the quantity 3t minus 1 cubed. In this example, we let u be equal to 3t minus 1 so that it will be easier to integrate. So, getting the derivative of u, we now have 3 dt. Simplifying, we have dt is equal to 1/3 of du. Now, we can substitute these variables in the given equation. So, we integrate u cubed, substitute dt, we now have 1/3 du. Since 1/3 is just a constant, we can apply the constant rule. So, we let 1/3 outside the integral sign. So it will be 1/3 the integral of u cubed du. Now performing the variable rule, we now have u raised to 4 over 4. Now we can substitute the u here, which is 3t minus 1. So it will be equal to 1 over 12, the quantity 3t minus 1 raised to 4 plus the constant c. So that's the end of the video. Please don't forget to subscribe and see you on the next lesson. Bye guys.